Welcome to the next session of subject Engineering Maths. We were discussing chapter 6, that is Laplace transforms. Now in this session we discuss classroom workbook, that is the questions based on basics of Laplace transforms, convolution product, how to find Laplace transforms of various functions like this. So let us start the session with classroom workbook. Question number 1. The Laplace transform of a plus bt whole square where a comma b are constants. Options are given. We need to find Laplace transform of a plus bt whole square. It is a function of time variable t, a and b are constants. So take that f of t equal to this. Now therefore here Laplace transform of f of t equal to Laplace of a plus bt whole square. So this is Laplace of, expand this by using a plus b whole square. So a square plus b square t square plus 2ab into t. Now between functions we have plus, so we can apply linear property. This is Laplace of a square plus b square into Laplace of t square plus 2ab into Laplace of t. Here also a is a constant, so it can be taken before Laplace. A square into Laplace of 1 plus b square into Laplace of t power n factorial divided by s power 2 plus 1 plus 2ab into Laplace of t power n value 1. This is 1 factorial divided by s power 1 plus 1. Here Laplace of 1 is 1 by s. So this is a square by s plus 2b square by s cube plus 2ab divided by s square. So just by using Laplace transform of powers of t and linear property, we got a square by s plus 2b square by s cube plus 2ab by s square. So the options are, I think a square by s is in two options, C and D. So a square by s plus 2ab by s square plus 2b square by s cube. This is option number C. Note this. The Laplace transform of f of t equal to cos of pt plus q. We need to find Laplace transform of this function. So we can do like this, expand this using cos of a plus b formula. So therefore this is actually cos pt into cos q minus sin pt into sin q, just by using the formula of cos of a plus b. So therefore Laplace of this f of t equal to, here q is a constant, p is constant. So this is Laplace of cos pt into cos q minus sin pt times sin q. Now p is constant, so there q is constant. So cos q is constant, sin q is constant. Now between functions of two variables t, we have a minus sign. So you can apply linear property by taking cos q outside. Cos q into Laplace of cos pt minus sin q into Laplace of sin pt. So therefore this is cos q into Laplace of cos at, s by s square plus a square. Here a is p. So this is s by s square plus p square minus sin q into Laplace of sin at. A is p. So it is a by s square plus a square. So this is a p by s square plus p square. Now in both the cases denominator is s square plus a square. So we can add numerators directly. Therefore this is s into cos q minus p times sin q whole divided by s square plus p square. So therefore this is the Laplace transform of cos of pt plus q. Just we have applied cos of a plus b formula. Here p and q are constants, t is a variable. So we have applied linear property and then we have applied the Laplace transforms of cos pt and sin pt. So we were getting this s cos q minus p sin q by s square plus p square. So option A is right answer. Now let us discuss question number 3. A delayed unit step function is defined as u of t minus a equal to 0 if t less than a, 1 if t is greater than or equal to a. So the function has a split. It is called split function basically. So before a, the function is 0. From a onwards, the value is 1. Its Laplace transform is. Now let us write the Laplace transform of a function. Generally Laplace transform of this u of t minus a. This is nothing but generally integral 0 to infinity e power minus st into f of t. Here f of t means u of t minus a. So this is the Laplace transform of a unit step function u of t minus a just by definition. But here the function has two different forms. Below a it is 0, from a onwards it is 1. So we can change the integration limits like this. So this can be written as integral 0 to a e power minus st into u of t minus a dt plus integral a to infinity e power minus st into u of t minus a dt. So as per this definition, we have changed the limits of integration 0 to a and a to infinity. Now below a the value is 0. So this integral will be anyhow 0. So we need to focus on this. Therefore this becomes integral a to infinity e power minus st into, here it is 1 dt. Why this integral is 0? Because up below a the value of u of t minus a is 0. So this integral becomes 0. So rest integral will be between the above a, the value becomes 1. Therefore u of t minus a is 1. Now it becomes a single integral. So therefore this is integral a to infinity e power minus st dt. Now do integration with respect to t. So s is constant. So its integral is e power minus st by minus s, limits are from a to infinity. So therefore this minus 1 by s you can take outside. This is s into infinity, infinity e power minus infinity minus e power minus s, t is replaced by a because these are limits of a. Limits of t and s is constant. So this is minus 1 by s into e power minus infinity is 1 by e power infinity minus e power minus as. E power infinity infinity, 1 by infinity is 0. Therefore the final Laplace transform becomes 1 by s into e power minus as. Therefore the option is, this is 1 by s into e power minus as. Option B is right answer. Now let us discuss question number 4. Given that y of t equal to small y of t equal to e power minus t times 2 cos 2t minus sin 2t. So small y is function like this, e power minus t times 2 cos 2t minus sin 2t. Now its Laplace transform, that is capital Y notation, y of s equal to 2s divided by s plus 1 whole square plus 4. 2s by s plus 1 whole square plus 4. Then they were asking the Laplace transform of another function. The function is given like this, e power t into 2 cos 2t minus sin 2t. So they were asking Laplace transform of this function. So assume that this is f of t, for example. So we need to find the Laplace transform of this function. Function y of t is given like this. Capital Y is its Laplace transform in terms of signal variable, and they were asking to find the Laplace transform of this particular function. Now let us see the correction between the given function and this function. So actually when you multiply this function with e power 2t, this part is common, 2 cos 2t minus sin 2t. 2 cos 2t minus sin 2t is common. Only the difference is in the power of exponential function. This is e power minus t and this is e power t. So when you multiply this entire function with e power 2t, we get this. Therefore, the function f of t is, this is e power 2t times y of t. So multiply this with e power 2t, we get this. Therefore, the Laplace of small f of t equal to Laplace of e power 2t into y of t. Now apply shifting theorem. This is in the form Laplace of e power at into y of t. Here a value is 2. So therefore, this is by shifting property. This is y of s minus 2. This is by shifting property. So therefore, in this answer, replace s by s minus 2. This becomes 2 times of s minus 2 divided by s minus 2 plus 1. This is s minus 1 whole square plus 4. So 2 times s minus 2 by s minus 1 whole square plus 4. So option A is right answer. Note these points. Now we discuss question number 5. Given that f of t equal to 2 times square root of t by pi, its Laplace transform, this is capital F of s. This is given as s power minus 3 by 2. S power minus 3 by 2. Then the Laplace transform of g of t equal to square root of 1 by pi t is blank. So f of t is given like this, a function in the variable t. Capital F is its Laplace transform. Even it is given, this is s power minus 3 by 2. So they were asking to find the Laplace transform of this function. That means we need to check the connection between f of t and g of t. So when you divide this function with t, you will get this f of t by t. Then you can go for division by t. Even without this problem can be handled very easily also. We can do it directly. Here Laplace transform of g of t is Laplace transform of 1 by square root of pi t. So 1 by square root of pi is constant. Apply linear property. 1 by square root of pi into, this is Laplace of t power minus 1 by 2. So this is 1 by square root of pi into, this is a t power n. Laplace of t power n. N is a fraction value. So don't write factorial. We can use gamma function version. So therefore this is gamma of minus 1 by 2 plus 1 divided by s power minus 1 by 2 plus 1. So this is 1 by square root of pi into, this one is gamma of 1 by 2 divided by, this is s power 1 by 2. Gamma of 1 by 2 is root pi. Root pi will be cancelled. So this is s power minus 1 by 2. So the answer is option number B. Next question number 6. Given a function f of t like this, this is t and this axis is function f of t. So this is 1 and this one is 2. This is 2. This is f of t. So t is on x-axis, f of t is on y-axis. So they were asking the Laplace transform of this function. What does it mean is, when t is, this is origin. When t is ranging from 0 to 1, the function is 2. Above that, it is 0. So therefore, f of t is given like this. F of t equal to 2 if t lies between 0 to 1 and 0 elsewhere. So we need to find the Laplace transform of this function. This is one important model. Function is not given directly, but instead of function, its graphical representation is given. So you need to define your own function based on this graphical representation. So from 0 to 1, this is a constant function. So it is 2. From 0, when t lies between 0 to 1, f of t is 2. Outside it is 0. So we need to find Laplace transform of this. So here Laplace transform of f of t is, you can apply integral 0 to infinity, but here t limits are ranging from 0 to 1 only. You consider only 0 to 1. So 0 to 1 e power minus st into f of t is 2 into 2 dt. So 2 is a constant, you can take outside. Integral e power minus st by minus s, limits are from 0 to 1. So therefore this is minus 2 by s. Replace t by upper limit, you will get minus s. Replace t by 0, e power 0 is 1. Therefore this is nothing but 2 by, this is minus 2 by s into e power minus s plus 2 by s. Or this is like this, 2 by s minus 2 by s into e power minus s. So therefore s is common, you can take. So you can do like this. This is 2 minus e power s by s. So it is option number C. Now we discuss question number 7. If x of s is the Laplace transform of a function x of t, so capital X of s is a Laplace transform of small x of st, and this is given by x of s equal to s plus 2 divided by s plus 1 into s plus 3 whole square. Then the value of x of t as t tends to infinity. So small x of t is not given, but instead of that its Laplace is given. Small alphabet represents a function in terms of time variable. Capital version represents its Laplace transform in terms of signal variable. So this is not given, but its Laplace is given. So they were asking the value of x of t as t tends to infinity. So that means this is final value. So according to final value theorem, the value of final value is limit t tends to infinity x of t. But here x of t is not given, capital X of s is given. Therefore, here this can be written in terms of s variable, limit s tends to 0, s into x of s. So this is limit s tends to 0, s into x of s is s plus 2 divided by s plus 1 into s plus 3 whole square. So this is s into s plus 2 divided by s plus 3 whole square. Now replace s by 0. This is 0 into 0 plus 2. This is 0. Denominator is 1. This is 0 plus 3 whole square. Anyhow, this is 9. So the value of final value is 0. So therefore, this is by final value theorem. Limit t tends to infinity x of t. But small x of t is not given. Its Laplace is given. So therefore, in terms of limit s tends to 0, it becomes s times x of s. X of s is this value. When you try to replace s by 0, the denominator is non-zero, numerator becomes 0. So therefore the final value is 0. That's question number 8. If f of s equal to Laplace of small f of t equal to 2 into s plus 1 divided by s square plus 4s plus 7. Then the initial and final values of small f of t are respectively. So small f is not given, but its Laplace is given. They were asking its initial and final values. Let us see. The initial value is nothing but f of 0. So this is limit t tends to 0 f of t by initial value theorem. But here capital F is given, so this is limit s tends to infinity, s into capital F of s. So therefore this is limit s tends to infinity, s times f of s is 2 into s plus 1 divided by s square plus 4s plus 7. So here the highest power of s is s square, because s into s becomes s square. Here also s square terms are there. When equal powers of s are there, when you are applying limit value as s tends to infinity, take highest powers of s as common from numerator as well as denominator side. Otherwise you won't get finite value of limit. So this becomes limit s tends to infinity. Here I can take s square common, s square, this is square into 1 by 1 plus s into 2 divided by, this we can write it as s square into 1 plus 4 by s plus 7 by s square. Now s square gets cancelled. Replace s by infinity. Now 1 by infinity is 0. This is 2. Here 4 by infinity is 0, 7 by infinity is 0, but 1 is there. So it is 2. Therefore, the initial value is 2. We have only one option with initial value 2. That is option number B. So you need not find final value also. Even you can cross check it, you will get final value as 0. We have only one option. In option A, initial value is 0. In option C, 0. In option D, 2 by 7. Only in option B, the initial value is 2. Therefore, without second thought, you can opt for option number B. Now let us discuss question number 9. If x of s equal to 3s plus 5 divided by s square plus 10s plus 21 is the Laplace transform of small x of t, then x of 0 equal to. So small x is not given, its Laplace is given, then they were asking x of 0. This is initial value. So by initial value theorem, the initial value is given by limit t tends to 0, x of t. But here capital X of s is given. So in terms of signal variable, this is limit s tends to infinity, x into x of s. So this is limit s tends to infinity, s into x of s is this. So 3s plus 5 divided by s square plus 10s plus 21. Now when you replace s by infinity, it becomes infinity by infinity form. So we can go for L'Hospital rule. L'Hospital rule, that means finding derivative. So therefore this is limit s tends to infinity. The derivative of s is, this is 3s square. So 6s plus this was 5s is 5. So this is 3s square, derivative 6s, 5s derivative 5. This is 2s plus this is 10. Again it becomes infinity by infinity form. So apply L'Hospital rule once again. So this becomes limit s tends to infinity. The derivative becomes 6 divided by 2. So therefore this is 3. So therefore its initial value is given by 3. Option number B. Note this. Now let us discuss question number 10. The Laplace transform of e power 3 by 2 into at square plus bt plus c is s square by s minus 3 whole cube. So this is the function. Its Laplace is given by this function, s square by s minus 3 whole cube. Then here a is a constant, b is constant, c is constant. So they were asking to find the values of a, b, c. I think in every option a values are different, but b values there is some repetition, and c values are different. In the first option c value is 7, second option 12, third option 14, in the fourth option it is 2. So you can find either a or c to get the answer easily, right? Now let us see which is flexible, either a or c to get the answer easily. So one way is you can find the Laplace of this function at square plus bt plus c divided by 2, and then apply shifting property e power 3 by 2, and then your Laplace transform can be compared with s square by s minus 3 whole cube. You can easily get the values of a, b and c. So it may take some time, but this can be handled very easily. Let us see. Let us try to find c value. Here this is f of t, for example, and this is f of s. So here initial value is given by limit t tends to 0, f of t. So replace t by 0. This initial value becomes c by 2. So here f of t is given, capital F is given. I am trying to apply initial value theorem by taking f of t as well as f of s. So therefore initial value becomes limit t tends to 0 f of t, we get c by 2. This is again same as initial value equal to limit s tends to infinity s into capital F of s. So therefore this is limit s tends to infinity s into f of s. This is s cube divided by s minus 3 whole cube. Now you can simplify, you can take s cube common. This is the limit s tends to infinity s cube divided by, when you take s cube common you will get 1 minus 3 by s whole cube. So s cube gets cancelled, replace s by infinity, this is 1. So according to first one, initial value is c by 2. According to signal variable, the initial value is 1. So both must be equal. Therefore c by 2 equal to 1. Therefore the value of c is 2. So therefore option D is right answer. Now let us discuss question number 11. If Laplace of small f of t equal to s plus 2 divided by s square plus 1, comma Laplace of g of t equal to s square plus 1 divided by s plus 3 into s plus 2. So this is Laplace of f of t and this is Laplace of g of t. H of t is given like this. H of t is integral 0 to small t f of capital T into g of small t minus capital T dt. Then they were asking Laplace of h of t. Laplace of h of t. Now basically this is nothing but convolution product of f of t and g of t. This expression by definition, this is convolution product of f of t and g of t. Therefore here h of t is nothing but the convolution product, that is f of t star g of t. This star represents convolution product. Now apply Laplace. So Laplace of h of t equal to Laplace of f of t star g of t. Now apply convolution theorem. By convolution theorem, L of f of t star g of t is L of f of t dot L of g of t. This is convolution product, this is normal product. So therefore here L of f of t is s plus 2 divided by s square plus 1 into, and this is L of g of t. So s square plus 1 divided by s plus 3 into s plus 2. So s square plus 1, s square plus 1 gets cancelled, s plus 2 gets cancelled. So therefore the final value is 1 divided by s plus 3. So option B is right answer. This is nothing but convolution product definition. So this is convolution product of f of t and g of t. So h of t can be written as f of t star g of t. Therefore Laplace of h of t is L of this. Now at this moment we have applied convolution theorem. So L of f of t star g of t is L of f of t dot L of g of t. Now multiply these two Laplace transforms, we get 1 by s plus 3. So option number B is right answer. The lecture is over. Thank you so much.